Okay, children. Let's finish 111. Okay. Just kind of a quick little 111 today, 112 Monday, 13 Wednesday, review Monday, test Wednesday. That should be October 1st. Okay. We took that quiz, right? If you want to retake that, get that done before that Wednesday. I thought the grades would have been a little bit higher than they were on that, but if you want, I was going to go over it, but I'm afraid those that didn't take it will need an opportunity to take two. We only have two tests of it. The first one was real bad. That was the very first one, and some of you said it didn't factor. It didn't have to factor. I thought that was a hint, right? It just was asking about the endpoints, or as it approaches infinity. So we're just looking for the horizontal asymptotes. Anytime you're looking for infinities or the endpoints. Okay, real quick. So we're going over. This is kind of like everything put all together. Okay, everything put all together. So we have a polynomial f of x, g of x. If you have a polynomial over a polynomial, it's a rational function. We know that g can never be 0. If g is 0, one of two things happens. We have a whole or we have an asymptote. One of those two things happens every time. There is never a point where this is 0 and you don't have one of those two. Okay? So a lot of times you'll see it without being factored. That's why I mentioned at some point you got to factor these things. And so we had to factor the numerator, factor the denominator. When we factored the numerator and then the denominator, we found out that we had an x plus 2 and an x plus 2 on bottom. Now that told me now it's a whole as opposed to an asymptote. And then that one's an asymptote. And then the domain, and then these are zeros. However, that's a whole, so it can't be a 0. However, it's a whole. Okay? I was getting ready to say a whole at 0, but it's not. A whole at negative 4/3. Vertical asymptote, yeah. So domain will go from negative infinity to negative 5, negative 5 to negative 2, negative 2 to infinity. So these things are defined for every real numbers except for when the denominator is 0 for the domain. We typically don't ask for range for these unless if we can graph it with our calculator. Range is, yeah. Factored form, vertical asymptotes, find the domain. Here's the second equation. So write the equation in factored form. So we factored it over here. There's the numerator factored. Here's the denominator factored. X cannot be 0, negative 5, or 4. 4 is a whole. 0 and negative 5 are asymptotes. Okay? And so that's where it's asking, find any zeros, find any values where it has a whole, find any vertical asymptotes, find any horizontal asymptotes, find the domain. Okay? And the domain is everything from negative, everything but those three. I told you, I need to clarify. I was putting a notation with a different notation. So you can't go from negative infinity to infinity and say x cannot be 0, negative 5, or 4. You can't do that. This is interval notation. This is set notation, and you can't put set notation with interval notation. So if set notation says you write it as a bracket, all real values of x such that x cannot be 0, negative 5, 4, and then you close the bracket. So that's set notation. You probably have never seen set notation. So I was putting those two things together. So you have to go from negative infinity to negative 5, negative 5 to 0, 0 to 4, 4 to infinity. Okay? So that's what you have to do on those. That's what the domain is. All right? And then I told you just use your graphing calculator. Get comfortable with your graphing calculators. You can use Desmos also. Okay? So, and it says sketch. sketch, so it doesn't have to be beautiful, right? You should see asymptotes. I think there's one at 0 and there's one at -5. So you should easily see those asymptotes with dotted lines. You should see a horizontal. I think this one had a horizontal. Is that right? At 0, yes, because the bigger on bottom. So you should see it's kind of hard to see a horizontal with the line already there. I just tend to extend it out past the line so you can kind of see it. Y-intercepts are pretty easy to spot. And then the hole, where the hole is, that's what, and then basically where the other stuff is. But you're doing this, or you're doing this, or you're doing it. You know, your calculator will show you all that stuff. But it's just sketches. You don't have to be perfect. Like I said, the things we'll look for are where we know things have to happen. The holes, intercepts, asymptotes. Those things are what we'll grade on that. Okay. All right. And then, what do we do there? Write the function. There, you know, some of we kind of struggled sometimes on what those are. They'll tend to help you out by not having to find something special. You know, you may have to throw a negative up there, but you typically don't have to throw constants in there. Okay, so once you find asymptotes and intercepts and holes, it makes those, if you find those things and make an equation for it, you typically are good. Do note that if you decide to multiply that out, it's okay. But if you multiply it out wrong, it's not okay. Right? So if you leave it like this, it doesn't say how to put it. Right? It doesn't say how to put it. It just wants an equation. That's an equation. That's an equation. So I try not to have you guys simplify unless it says so. Okay? So just kind of recognize those type of things. And then we did that one. Okay? All right. Just a quick recap. All right. This, you guys know, I know you guys did it in Algebra 2 a little bit. In fact, I heard from somebody, and this is what we did in Algebra 2 also. We taught you how to find the slants. I think we did some homework questions over slants, but we never tested over slants. That's the way, when I taught Algebra 2, that's what we did, and I heard from a couple students that's what they did. You'll be tested over this in pre-cal. Okay, you'll be tested over slants in pre-cal. Given a rational function, if the degree of the numerator is 1 more than the degree of the denominator, we have a slant asymptote. We talked about that, gosh, in whatever that was, 7, I guess, somewhere in there. And we talked about how it's parallel to. So, and today we've got to actually find the equation of the slant. Okay, if it's more than 1, there's not a slant. You will not see more than 1 in a pre-cal class. Okay, if the degree is more than 1. So here we have a function x cubed minus 4x over x squared minus x minus 2. Of course, the numerator factors into x plus 2, x minus 2. The denominator factors to x minus 2, x plus 1. So what makes this class, again, difficult? Why are you not full page? There we go, that's better. You could see it like this, or you could see it like that, right? Sometimes it's better to see it factored because, of course, then you don't have to factor it. Sometimes it's better to see it multiplied out. I think horizontal asymptotes are easier to see like this than like that. I think vertical asymptotes are easier to see like that. Zeros are easier to see like that. But you just got to be able to see both, okay? Bless. It has a hole at 2. So we know we have a hole at 2. We have a vertical asymptote at -1. We have a 0 at -2. We have a 0 at 0. Okay, so those are things you need to recognize from that. And what I mean by zeros, those are x-intercepts. Okay, so if I'm having to sketch some of this stuff, I'm drawing me an x and y axis, and I'm putting me a 0 at 0. That's the origin. I'm putting one at -2. I'm putting a vertical at -1, and then at -2, I'm just keeping something in my head so that I remember that there's a hole right there. And I probably would just go ahead and plug and chug a 2. 2, that's 4. 4 times 2 is 8. 2 plus 1 is 3, so it would be at 8/3. So at 2 8/3, I would put a hole. Okay? It says it's graphed above. Oh, There it all is. Okay, beautiful. So there's that vertical. There's that one intercept. There's the other intercept. There's that 8/3. Okay, so all that stuff you should be able to do. The y-intercept is 0 also. If the x-intercept is 0, the y-intercept has to be 0. The graph does not have a horizontal asymptote, but k of x does have a slant asymptote at y equals x plus 1. Since the degree of the numerator is 3, the degree of the denominator is 2, we know that the x will have a slant asymptote because the degree on top is greater than the degree on bottom, and it's bigger by 1. To find the equation of the slant asymptote, we have to use long division. You can use synthetic division if that's easier or better for you. So I'll show you both. I don't think he talks about synthetic. So long division, guys, let's just go through this because this is what you guys did sometime around 3rd grade, maybe 2nd grade. I don't know when they do it anymore. All right. So in the old method, it says 676 divided by 21. So that's 676 divided by 2, 1. Okay? And so when you're dividing this is the same way you're going to divide polynomials, exactly like this. I basically look at that 2 and I look at that 6. I don't look at the 1. And 2 goes into 6 3 times. So I'm going to try 3. 3 might be too big, but we don't know. So I'll just try 3. And I don't care where you put it. Then you got to do 3 times 1, which is 3. And then 3 times 2, which is 6. Or basically you're doing 3 times 21. And 3 times 21 is 63. And so that goes right here under the 6, and that's 7. Okay? And then here's the part where a lot of students mess up. You have to subtract that because you're taking that away after you divide it. And so we're left with a 4 and a 6. Okay? And then we take this 2 into that 4, which goes 2 times. So I'm going to put a 2 right here. Now I'm taking 2 times 21, which is 42. Remember to subtract, and we get 4 left over. And 4 is my remainder. At one point, you probably put a decimal and started dropping decimals down, and then that's where you would have your decimal answers. In polynomials, we don't have a remainder. So I can write this 676 over 21 is the same thing as 32 and 4 over 21. It's the same thing. 21 goes into 676 32 times with 4 left over 21. And if you can do that concept, then you can do long division. Okay? So let's go over here and do this problem here the exact same way. Notice that they got a 6 and a 7 and a 6 and a 2 and a 1. It's very similar to that over there. Okay, they're trying to link it all together. So we're going to do 6x squared plus 7x plus 6 divided by 2x plus 1. Okay? All right. Now, all I look at are the first terms, the 2x and the 6x squared. That's all I ever look at. I look at the very first thing. And if 2x does not go into it, then you have a horizontal asymptote at 0. That's why I don't do bigger on bottom. Even I just divide every time. If the bottom does not divide into the top, it has to be 0. If this is a 2x squared, if that's a 2x squared and that's a 6x squared, then it goes 3 times. So there's a horizontal at 3. So that's why I say I just divide every time. I don't have to remember anything. I don't have to add bigger on, just divide it. If it doesn't divide, it's at 0. If it does divide, then divide it. This one divides not evenly because we got an x. So 2 will go into 6 3 times. And again, I don't really care where you put it. And x will go into x squared with an x time, right? Remember we talked about how it's going to be parallel to the coefficient over the 2 or over the coefficient. with the x. So it's going to be parallel to 3x. We just have to find the y-intercept. It's going to be parallel to 3x. We just got to find the y-intercept. So we're going to take this 3x times the 2x, which gives me the 6x squared. And then I got to do the 3x times the 1, which is the 3x. And we put it right underneath the 7x. And if you didn't have a 7x, then you just got to put it by itself. Now, here's the part where students mess up. You have to subtract this. You have to subtract it. If this was already a subtraction, then you're going to turn it to a plus. Because anytime you subtract a negative, it's like adding, okay? Those should go away. If they don't go away, you did something wrong. You did something wrong if they don't go away. And then we got the 7x minus the 3x, which is 4x. And then I bring down the 6, but you really don't have to bring down the 6. Don't have to. Now the 2x will go into 4x just 2 times. Only 2 times, just like it went 2 times over here. So we're going to put plus 2. Now we're going to multiply just like we did over there. So 2 times 2x is 4x. 2 times 1 is 2. Subtract. Those go away. 6 minus 2 is 4. That's that remainder. Okay? This is what you need to know. I have changed this equation. I have changed 6x squared plus 7x plus 6 over 2x plus 1. That's what it looked like before. You see it like this, but that's what it looked like before. Bigger on top, you got to divide. Okay? Bigger on top, you look at 6 over 2. We knew it was parallel to 3x already. We just need to know the y-intercept. But so this changes to this plus 4 over 2x plus 1. So I just changed the look of that. That's what I did. It still has a vertical asymptote at -1/2. This one had a vertical asymptote at -1/2. -1/2. 1 divided by 2. Y'all haven't seen one of those yet. -1/2. So it's the same thing. This is the slant asymptote. Okay? I say that I think the reason why they don't do synthetic is because they want you to rewrite it. And it's a little bit better to do it this way. You can still do it synthetically. And I'll show you at some point. But you can still do it synthetically because you'll have the 3 and the 2 and then the 4 left over. And it's just your job to know that it's 3x and a constant and the 4 is the remainder, and you got to put the 4 over the 2x plus 1. This one's harder to do synthetically because you got to use -1/2. It's easier to use long division. Okay, so over here, I didn't answer these questions. I messed up on that. The quotient is, what, 32? With the remainder 4. That is there. Over here, the quotient, let me turn it back to blue. The quotient is 3x plus 2, which is your slant asymptote. The remainder is 4. And then the answer is what I have all up here. The 3x plus 2 plus 4 over 2x plus 1. So hopefully you guys did that. It wasn't too big of a trouble when you did it in Algebra 2. You'll have some practice on your homework. Okay? Beautiful. Beautiful. Let's go down. I bet we have an example of something. Here it goes. Now, y'all see this, right? Use long division. So if you don't use long division, you're going to get dinged because they're telling you what to do. Okay? If they tell you how to do it, make sure you do it that way. So we got 6x squared, x, 5, 2x plus 1. You should know already that we have a slant asymptote because the degree on top is 1 more than the degree on bottom. If it was 2 more, you don't have a slant, you don't have a horizontal, you have a crazy, crazy one, and you won't see that. You just say no slant, okay, because it says slant. So here we go. Let's make sure we do this. Let's do red. 6x squared plus x plus 5 divided by, that's what that line means, divided by. So divided by, and then I'm going to put 2x plus 1. Is that the same one? No, is that what we just did? Okay, but 2x plus 1 was 1. So it's parallel to 3x. 6 over 2 is 3. So it's parallel to 3x. We could have, like I said, we did that already in whichever lesson that was, 1.7 or 1.8, seems like. Now I got to multiply it. So this is going to give me that 6x squared. This is going to give me a 3x. And I got to subtract it. Don't forget to subtract. Again, those should go away. If they don't go away, you've divided incorrectly. And then I got a x minus 3x, which is a negative 2x. Use long division to find an equation for the slant asymptote. And so 2 will go into negative 2, negative 1 time. And I can almost stop right there because that is your equation for your slant asymptote. Be careful again, they could have said rewrite. So if they tell me to rewrite, I need the remainder. But they didn't tell me to rewrite or anything else. I just need the equation of the slant asymptote, which is y equals 3x minus 1, which means we have a y-intercept of negative 1 and a slope of 3. Up 3 over 1, up 3 over 1. So I'll put all those dots, and then I connect it with a dotted line. Okay? Yes, sir.
Would it be wrong if we added the remainder?
No. I mean, it would be for the equation of the line, but if you put it over there, you're fine, right? Y'all okay with what he said, right? If you wanted to put plus, what is the remainder? 6 over 2x plus 1, okay? And if you want to do that, that's fine, right? If they said rewrite it, then I would want to make sure that I put h of x equals, okay? That's what I want to make sure that I do. But again, all they cared about on this particular one was the slant asymptote, okay? All right. Good. Y'all okay? Y'all remember doing that somewhat in Algebra 2, yes? Example 7. G of x. I got an x cubed on top and I got an x squared on bottom. I'm going to have to do some factored form. In fact, it says factored form. So we got a factor. So on top, I'm going to go ahead and take an x out. Take an x out. When I take an x out, I'm left with x squared plus 4x minus 12. And on bottom, I need an x. Let's see, 6 can be 2 and 3, but 2 and 3 won't give me 7, so I need a 6 and a 1. And this one, I need x. I'm going too fast, I guess. 12 can be 4 and 3, but 4 and 3 can't give me 4. So I need a 6 and a 2, and the 6 needs to be plus. Plus 6x minus 2. And then we already have x plus the 6 and x plus the 1. All right, let's talk. From here, right? Oh, I really should do equals g of x. Okay, from here, you know the domain. Negative infinity, negative 6. Negative 6, negative 1. Negative 1, infinity. That's the domain, no matter what. No matter if they're holes or asymptotes or whatever else. So we know the domain. Does it ask me that? No. So factored form. There's the factored form. This is an x. Okay. Make sure you put the function with it, okay? Make sure you put the g of x with it. Vertical asymptotes. There's only one vertical asymptote at -1. So let's put x equals. Put x equals on vertical asymptotes. Horizontal asymptotes, we decided there isn't one. Not one. No. Zero. Don't put 0 because then it looks like there's one at 0. Right? So not available, not one, empty set, stupid question, whatever you want to put, right? And in slant asymptotes, we decided the degree on top was one more. So we got to figure that out. So y equals, and then we got to do our long division, okay? So let's go back to our long division. Let's do x cubed plus 4x squared minus 12x. And then I got x squared. This one you can't use synthetic either. I guess that's why he does long division. Plus 7x plus 6. X squared will go into x cubed, x times. Which we already knew that because the coefficients are 1 over 1. Right? We already knew that from 1, again, I can't remember if that's 1.7 or 1.8. And so this, now x will go here, which gives me an x cubed. This is going to start getting a little narrow. This is 7x squared. And again, I really can stop, truthfully. We'll go ahead and finish it out. But I don't need that 12 over there. This will be a, what, 6x. Positive 6x. I'm going to make it a negative 6x because I got to subtract. This will go away. This gives me a negative 3x squared. You got something, Charlie? Oh, you're just stretching out? Okay. So I'm sorry, this is getting nasty right here. I got really tight. I should have done it over here. Negative 3x squared. Again, I really can stop over here because all I care about is how many times x squared goes into negative 3x squared. Y'all see what I'm saying on that, right? I don't really, all I need is a constant and I need the coefficient. I'm guessing I messed up somewhere. Oh, there. I saw 2 hands go up and I knew I messed up. Again, we don't care what that says. Good? But I did mess up. First mistake this year. Yep.
I was wondering, so I had done it, I go back to the original equation, so I just done it after like removing the holes and stuff. Is that like accurate most times?
So you can do it. No, that works.
Like, I wasn't sure if it was like
No. No, it works. So because this is an x plus 6 and an x plus 6 over itself, you can take it as x squared minus 2x and divide it by x plus 1 and get the same thing because it simplifies. Y'all okay with what? I mean, it's just like 2 over 2. It simplifies. If you got 2 over 2, you like that to be simplified because it just makes life a lot easier for us. So if it does simplify like that, you can go ahead and do that. I would, if it just asked me for the slant asymptote, I wouldn't even factor the stupid thing. I just go with it. Because if you factor it wrong, then you're going to get the wrong asymptote. I don't want to do something that could possibly cause me to mess up somewhere else. Just use what it does. But great question, great point. And y'all follow what I'm saying about it doesn't really matter about this other stuff over here because all I need is that slope and the y-intercept. And so really, I didn't care what this was. I really didn't need that. Because all I need is this into this. Then I got to have that part to see what I'm going to subtract to, but then that's what's going to lead me to the next coefficient or the constant. Yes, no, maybe? What else we got? Oh, we got a multiple choice one. Multiple choice one. Which of the following about the graph is correct? Okay, so wow, we're all the way up to d of x. So we got to start using our little cranium up here. We got a 2x, we got an x, and we got an x. So that's 1, 2, 3 x's. So we have an x cubed on top. We have an x squared on bottom. Okay, so bless you. So now, bless you 2 times. And so now I know for a fact that I don't have a horizontal asymptote, I got a slant asymptote. I know that I possibly could have 2 vertical asymptotes, or I could have 2 holes, or whatever. But I'm just kind of thinking about all that stuff before I even look at these answers. Okay? Now I'm going to go to my answers, and after I've thought about all this, let's see what happens. Has 1 horizontal asymptote. It can't have a horizontal. If it has a slant, it can't have a horizontal. It's a or. It's a horizontal or a slant or none. Man, what the heck? Y'all allergic, man? So it does not have a horizontal. Whoops, I need a pencil. It does not have a horizontal. Has 1 horizontal. Guys, this is so common for these. You always have 4 choices. 2 of them are always immediately wrong. And then you have a 50-50 shot. Has 1 slant, 1 hole, 1 vertical. Has 1 slant, no holes, 1 vertical. So now I need to factor the C. Luckily, they've already factored the top for me, so I need to factor the bottom. And x squared minus 2 plus 1 is maybe one of the easiest things in the world to factor because there's only 2 things that give me 1. 1 and 1. So it'd be an x minus 1 and an x minus 1. So I have an x minus a 1. Oh, this is a great question. And then I have an x minus 1 on top. So this one can get this one to help me simplify it. But what does that mean now? I still have 1 on the bottom. And if you still have an extra 1 on bottom, then that's going to give me a asymptote. If it's left over on bottom, it gives you an asymptote. If it's left over on top, it's okay. That just gives me an extra 0. So that would be a hole, okay? It'd be a hole. But if it's left over on bottom, that has to be an asymptote. So it has 1 slant, no holes. No, you can't have an asymptote with a hole. It's either a hole or an asymptote. It doesn't, once it gets to asymptotes, guys, it just shoots way up or it shoots way down. It doesn't jump over and just do the same thing. It just can't do that. So it has 1 slant, no holes, 1 vertical, D. D. Sketch a picture of the following. This might be one of your free response questions. I'll tell you, you'll know it by May what they are. But so the limit as x is approaching infinity is negative infinity. What?
I'm sorry, going
it's okay.
back to example 8,
Yep.
you said that there can be a slant asymptote or a hole, not both.
It can be a vertical or a hole. Yep. Yep. You can't have, let me rephrase that. I may have said it. You may have heard what I said and I said it wrong. It can have a hole and a vertical. It just can't have a hole where the vertical is. I'm glad you clarified that up for me. I said what I meant to say. I just said it wrong. Yeah. You can have a hole and a vertical. You just can't have a hole where the vertical is. Okay. So limit as I'm going to infinity is negative infinity. So I can almost draw that. Limit as I'm going to negative infinity, I'm going to positive infinity. Good? Hopefully I got enough room in there. As I'm approaching -1 from the negative side, I'm going to negative infinity. So that has to tell me that has to be a vertical asymptote. At -1 has to be a vertical asymptote because that's the only way I can go to infinities, is it has to be in the asymptotes. So at -1, I have an asymptote, okay? And at -1 on the negative side. So I don't know how this is going to happen, but I'm guessing you have a slant because you're coming down here and at some point you're going to negative infinity. Well, the only way I can do that is if I turn. And so I'm going to turn and shoot that thing down to negative infinity. And the same thing here, because as I'm going on this side, I'm at negative infinity. Yeah. My guess is I have like a slant in here somewhere. But what, 29 of you cats in here, and you can draw it 29 different ways. As long as you got an arrow here, 2 arrows going down, and you got this arrow going down and that arrow going up. And that's all they gave me. They gave me sketch a picture of the rational function with the following properties. Is that 4 different sketches or is that 1? I think it's 1 too. I mean, surely to goodness, if I just give you number 1, you can draw a million of those. That's exponential. Yeah. We'll go with that. I would have liked for them to give me the slant, but. All right, here we go. Completely new topic, brand new, brand new. I don't think you guys have covered this, okay? So this is one of those type of things we're not really sure where it fits. We're not really sure where it fits. We're going to put it now, okay? It kind of goes with polynomials. So we're going to talk about 2 things, Pascal's triangle and the binomial theorem, okay? And I say I'm going to talk about 2 things. I'm not really going to talk about 2 things. I'm really just going to talk about Pascal's triangle, because here's what I found out when I taught this 2 years ago. When you got to the test, nobody remembered the binomial theorem. You didn't. You remember Pascal's triangle because it's just kind of cool and kind of neat. So most everybody remembers that. We don't remember the binomial theorem. If you don't remember it, then why even try to teach it? Because you're not. You can use either one. You can use either one. I'll go over it just enough to go over it because I think it's kind of cool mathematically, but most of you guys are going to use Pascal's triangle. Okay? You have enough time to do that. So let's just kind of keep that in our little heads. All right, so you guys know, let me do this. Let me tangent off of that for just a second. Clear, blank white screen. I'm going to tangent off my notes for just a second. Y'all just kind of watch. All right? X plus y, good enough? Binomial to the first power. This is the one where we'll get Algebra 2 students to mess up. By the time you get to pre-cal, you don't mess it up as much. It's not x squared plus y squared, right? Because you have to do the outers and inners, because you have an x plus y and another x plus a y. So you have to do the x times the x and then the x times the y, and then the y times the x and y times the y, right? So you end up with x squared plus 2xy plus y squared. Okay with that? And if I, by crazy some chance, I did an x plus y cubed, now we're starting to get a lot more difficult, right? And for punishments, what I used to tell students is I used to make them do x plus y to the 5th power. Because you got to do x plus y times x plus y times x plus y times x plus y. So then you get a trinomial, and you'll get another trinomial times another binomial. And it's mean, right? So anytime you have a binomial raised to some power, then you can simplify that by using the binomial theorem, or the binomial, is that, yeah, binomial theorem. Guys, you know, about done? Say the binomial theorem, or you can use Pascal's triangle, okay? So let me just quickly show you Pascal's triangle. Pascal's triangle starts off with a 1 up top, and then you put a 1 down here and a 1 down here, okay? So that's the first one. This is x plus y. That's x plus y. And then below that, now we're going to put a 1 out here and a 1 out here, and then those 2 ones go together, and you're going to make a 2. Because when you put 2 ones together, you get a 2. And then you're going to put a 1 out here, and you're going to put a 1 out here, and then this 1 and this 2 is going to make a 3, and then this 1 and this 2 is going to make a 3. Okay with that? And it just keeps on going. So this is the squared one. See how it says a 1 and a 2 and a 1? A 1, a 2, and a 1. So the cube's going to make a 1 and a 3 and a 3 and a 1. And then the fourth is going to make a 1 and a 4 and a 6 and a 4 and a 1. Y'all okay? Hopefully it doesn't make me do to the 20th. Because if it did to the 20th, you'd have to take this thing all the way down until you got to the 20th. Okay? They don't do that, but that's why we have the binomial theorem, because the binomial theorem will do it with just that. Okay? They typically, the max I've seen is 7. The max I've seen is 7, so you have to take this down a little bit further to 7. And so what you do is you have scratch paper, right? And at some point on the scratch paper, you'll just make your binomial, you'll do your Pascal's triangle on it. But I wouldn't do the whole thing because you don't know where you need to go to. Y'all kind of follow what I'm saying? There's plenty of time on this test to be able to do that. Yes, sir? That represents the coefficient. This represents the coefficient. So I'm going to cover the exponents in just a second, but this represents the coefficient. Okay? Yep.
How long is
8.5 by 11. I don't remember. It's 3 hours total. 3 hours total.
How many questions?
2,800. I don't remember. Okay. All right. So that's what I mean by all this stuff. Let's go back to my notes. Okay. Let's go back to my notes. Expanding expressions a plus b, so they went a plus b instead of x plus y, to the n power can be tedious. Let's expand x plus 3 squared. That's not that tedious because that becomes x squared plus 6x plus 9. Then I have x plus 3 cubed. Well, then I got to take x squared. So here we go. This is x squared plus 6x plus 9 because the x is going to go that. Then the x is going to go with that 3. This 3 is going to go with that x. That gives me the 6. And then this 3 gives me that 9. Okay? Then this next one. Well, I already got that. So I got to multiply it again by an x plus 3. So then I'm going to get an x cubed. And then this x times that's going to give me a 6x squared. And then I'm going to take the 3 times that x squared. So that's 6x squared, and that 3x squared is actually going to give me a 9x squared. Just trust me on all this, right? And then I got to do what? Then I got the 3 times the 9, which is the 9x. 3 times the 9, which is the 9x, and I got to do 3 times that, which is the 18. And the 18 and the 9 gives me 18, 19, 20, 21, 22, 27 x by itself. Just trust me on all this. And then 3 cubed is 20, also 27. Okay, I think that's right. Good enough with all that? So if I told you to take it out to the 4th, then we got to do x plus 3 again. And so we got to do x times each one of those. Then we got to do 3 times each one of those. And then we got to combine our like terms. And there's always going to be some kind of like terms in there and whatever. Okay, so it becomes tedious. Not real difficult, but the only way it's going to be difficult is because it's just so long and tedious, right? A lot of places to make mistakes. What if we wanted to expand x plus 3 to the 7th? Again, we don't want to take x plus 3, 7 of those bad boys, multiply 2 of them together, then multiply it times another one, then multiply. I mean, it would just take forever. Take a whole sheet of paper. As you can imagine, this would be very tedious, time-consuming, and using a method from above. Fortunately, there's a great mathematical property and tool to make this process much easier for us. So here's the binomial theorem. I'll pass that up, okay? Because again, you can kind of see it looks a little worse, okay? This first formulas of the binomial theorem were mathematicians by those two around 1000 AD. Who cares? That's not a test question, right? At first glance, the binomial theorem may look intimidating and complicated, but in reality, it's easy to use and to understand if you remember a few details. When expanding the binomial, A begins with degree n. B begins with degree 0. That you need to know. A begins with degree n, B begins with degree 0. Let's go back. A begins with degree n. A begins with 2. B, 3, begins with degree 0. There's no 3. Then we got A to the first power. So there's only one x, whereas 3 is to the first power. But there's the 2 there still. So it starts off with A being to that, B being to 0. And then the next one, A drops 1 and B adds 1. A drops 1, B adds 1. A drops 1, B adds 1. Until you get done with A's not having any more and B has the same power. That you kind of need to know as we'll go through it. That's important. Okay? That's important. So when expanding the binomial, A begins with degree n, B begins with 0. As we expand the binomial, the degree of A decreases by 1 each term. A has degree n, n minus 1, n minus 2, n minus 3, n minus 4 until I get to 0. B starts with 0, B1, B2, B3, B4 until I get to Bn. Okay? Increases by 1 until we get to n. So that you need to know. And then it says now we can use Pascal's triangle. So the binomial theorem gives me the coefficient that I need. Just go along with me right now. It gives me the coefficient I need. Pascal's gives me the coefficient I need. So they both give me the coefficient. Pascal's is easier for students than the binomial. Okay? Because we don't go to such a huge number. All right? So here's Pascal's triangle. 1, row 1. Here's row 2. I know this is really row 3, but row 1 doesn't count. The 1 by itself doesn't count because this is the raised to the first power. This is raised to the second power. This is raised to the third power. Raised to the fourth power. Okay, so the first number out here is telling you the exponent. Okay, telling you the degree. The first number in each row is the 0. All right, so here we go. Why do we have this? Oh. There's no reason to, I don't know why that's circled yet. Okay, here we go. All right, here we go. Example number 10. There's one of these on the test and students always mess up on it because it's just, I don't say always. You pretty much get it right or you get it wrong because you don't understand what's going on. Use Pascal's triangle to expand x plus 2 to the 5th. So this is what I'm going to do first before I do anything at all. And I'm going to put a big old space between all this stuff because I got to do some fixing. So I'm going to start off with x to the 5th. And then I'm going to put 2 to the 0. Everybody okay with that? Starts off with a degree or starts off with that exponent. And then the second one starts off with 0. And then I'm going to put me a space. Okay, and I'm going to put x to the 4th, 2 to the 1st. Okay, and then I'm going to keep on going until I basically get to x to 0, and I'm going to end up getting 2 to the 5th. And if you don't end up with 2 to the 5th and 0, then you've done something wrong because it has to go that way. So we're going to go x3, and then 2, 2. Your exponent should add up to 5. Your exponent should add up to 5. 4, 1, 3, 2. Now I'm going to go 2, 3. And now I'm going to go 1, 4. And then 0, 5. Let me soak that in for you guys. Y'all okay? Good? Yes? No? Questions? Okay. We are 80% done. Now we just got to have the coefficients. We got to have the coefficients. And so I want to the 5th degree or the fifth power, okay? So what I'm going to do, I'm going to cheat because Pascal already went to the fifth up here, right? 1, 5, 10, 10, 5, 1. 1, 5, 10, 10, 5, 1. So those are the coefficients that I'm going to put with this polynomial. 1, 5, 10, 10, 5, 1. Now we're about 90% done. Actually, we're more than, we just got to simplify it. We're done, except we just got to simplify it. 1 times 5 to the fifth times 2 to the 0. 2 to the 0 is, anything to the 0 power is 1. So this is just going to end up being x to the fifth. X to the fifth. This is 5, x to the fourth, 2 to the 1. And 2 to the 1 is 2. So 2 times 5 is 10. Good. This is 10, x cubed, 2 squared. 2 squared is 4. 4 times 10 is 40. That's 10, that's x squared, and that's 2 cubed. And 2 cubed is 8. 8 times 10 is 80. And that's 5, and that's x, and that's 2 to the fourth. And 2 to the fourth is 16. And 16 times 5 is 6, 7, 5, 80. And then I got a 1, and I got a 2 to the 0, and I got a 2 to the fifth. And that's 32. Yes, no, maybe? That's a whole lot easier than taking x plus 2 times x plus 2 times x plus 2 times x plus 2 5 times. Okay? Question. Let's go to the next one. Let's go to the next one. Two x minus 1 to the fourth. Now this is where they start getting a little bit harder, okay? Because you got a 2x. So 2x to the fourth power, you might want to put that in parentheses because the 2 has to go to the fourth also. It's not 2x to the fourth, it's 16x to the fourth. Just like the 2 was. And then I got negative 1 to the fourth. So I got to put negative 1 to the fourth. Okay? And then I'm just going to drop and add, drop and add, drop and oh, sorry, that's 0. That's 0. Whoops, my bad. I saw a bunch of confused looks. Drop, add, drop, add, drop, add until I get to 0, 4. So we'll go 2x 3, negative 1, 1. 2x, oops, see I didn't put in parentheses. 2x2, negative 1, 2, 2x1, negative 1, 3. I'm not going to put 2x because I'm out of room. But 2x0 is 1, right? 2x4, 2x4, that's 16x4. I got to get my coefficients. Let's do my coefficients. I better do my coefficients. 1, I got them handy. What are they? 4, 4, 6, 4? Questions? Y'all okay with what now it's just simplifying. Once you get here, you're good. Once you get here, you're pretty good. So this was 16x4. I almost put plus, but it's not plus because it's going to be minus because you got one negative sign. One negative sign. And 2 cubed is 8, and 8 times 4 is 32. Now I got 2 negatives. And 2 squared is 4, and 4 times 6 is 24. And then I got 3 negatives. And I got a 2 and I got a 4, which is an 8. And then I got 4 negatives. Any questions about how I got any of those values? You guys can see how many places you can mess up on that, right? Now this one is, what is the coefficient of the term containing x to the 4th? And so x to the 4th, we start off, so I'm just going to, I think the best way to be sure about this rather than think about it is I'm going to start off with x to the 6th. Okay, I'll start off with x6. So x6, 5, 0. And then I'm going to go x5, 5, 1. x4, 5, 2. I can stop because all they care about is the x4. You guys are smart. You probably can skip this and just go to here. But I need the the triangle coefficient, right? And so this is a 6 degree. So I got to go my little 6, and it goes 1, 6, 15. 1, 6, 15. Okay? They want the coefficient. Well, it's not 15 because you got a 25 that goes with it. So you got 25 and 15. I don't know what that is. 375. Thank you. So it's 375. And that's all they want, guys. They just want the coefficient. They just want the coefficient. What is the coefficient of x cubed? All right, last one. Good. X cubed. Man, I don't know if I really want to start off with x8 all the way down to x3. I think I'm going to start off with x0 and go to this way. Y'all see what I'm saying? I'm going to do -3, 8, x0. This would be -3, 7, x1, x2, x3. Y'all with me? If this is 8, that's going to be 7, it's going to be 6, and it's going to be 5. It should add up to 8. They should add up to 8. So I need -3 to the 5th. That should help you. The exponent should add up to this. Okay? All right, so now this was the first, which that has a coefficient of a 1, 8. Did he go all the way down to 8? He didn't go all the way down to 8. You already did it for me though. 1, 8, 28, 56. 1 for the 0, 8 for the 1, 28 for the 2, and 56 for the 3. Y'all kind of see how I'm doing all that, right? So y'all had to take that one more down on your Pythagorean or your I'm Pythagorean theorem. Pascal's triangle. Go ahead. Brock, are you not Brock? Sorry. Are you going Featherstone? You going too? Is it just y'all or is it y'all? I thought it was. Well, I know, but I thought it was Men in Black too. It's okay. So now I got to do -3 to the 5th. That's -3, -3, -3, -3, -3, -3. So it's going to be negative. Okay. And you got these little TI things that are going to help you tell you what that coefficient is, because then you got to multiply it times 56. 13,608. Yippee, yippee, yo. So, it's not that difficult, but but guys, time is not an issue for the AP test for you guys. It might be an issue on the class test, but it shouldn't be because we're still timed the same. Okay, I'm DUN. You have what? 111 for homework? Due on Monday. Okay, due on Monday. Due on Monday. Let's go here.